All right, in this sample problem, we're going to find the pH of a weak acid when we know the Ka. And the first thing we need to do is we read the problem. It says calculate the pH of a 0.02 molar HCN solution. And they give us a Ka value. The Ka is 4.9 times 10 to the negative 10th. So we need to write an equation. So HCN, we know it is a weak acid. It's not one of the strong ones. So it's going to form H plus and Cn minus ions. We know that we are initially, we're going to go ahead and start our ice chart. We know that we are initially given 0.0, we'll go ahead and fix that because that will be messy, 0.2 molar HCN, and we're given nothing of the other substances. We are going to change by a factor of x. We're going to increase these by x. And we're going to decrease this by x. So 0.02 minus x. All right, so we are going to set up our equation. 4.9 times 10 to the negative 10th is going to equal x squared over 0.02 minus x. Now, here is a case where we're going to look at the assumption. We are dealing with a number that is 10 to the negative 10th for our K value, and we are looking at 10 to the negative 2nd for our value when we're dealing with x. So we know that there is going to be very little change involved in this value here. So we are going to be able to assume that the amount that we're going to subtract from x is negligible. So we're going to make that x disappear, which makes this problem much more easy to solve. All right, so as we continue, now we're just going to do our algebra, and we're going to take our 4.9 times 10 to the negative 10 times our 0.02, and that will equal x squared. And so we'll go ahead and do that math, and we're going to have 0.98 times 10 to the negative 10th equals x squared, and then I'm going to square root that, and I will get 9.9. Sorry, my stylus is not cooperating very well. 9.9 times 10 to the negative 6th, and this is molarity. Okay, that is equal to our H plus concentration. To find our pH, we are going to do negative log of that value, and we are going to end up with a pH of 5.00. I can't put my value in there, I don't have enough room. So when we plug in our 9.96 in there, we're going to take negative log and we'll get pH of 5.00. If you're looking at your sig figs, we have 2 sig figs here. So our 2 sig figs are to the right of our decimal place there. Okay, so here is a sample problem for you to try. What is the pH of a 0.010 molar solution of niacin? And niacin's Ka is 1.5 times 10 to the negative 5. And I am giving you the answer right here. Your answer should be 3.41. So go ahead and work that problem out and see if you can get to that answer. If you can, great. If you cannot, then we need to practice. Obviously, we need to practice more in class. So we will be doing more practice with this type of problem in class, and make sure that you bring up any concerns or questions you have.